You know, every time we step onto a plane, we're basically trusting 1,000 hidden engineering marvels to work perfectly. Today, we're going to pull back the curtain on a couple of the most brilliant solutions that are hiding in plain sight. And we're starting with a question that honestly seems to defy all logic. I mean, think about it, right? It feels completely backwards. You've got this massive, super protected tube, the fuselage, where everyone is sitting. So why on earth would engineers store tens of thousands of kilograms of flammable liquid way out in the wings? It seems like the absolute last place you'd want to put it. Now, the common explanations you hear actually make some sense on the surface. You know, it saves room for people and bags, or the wings are just empty space, might as well use them. But if you stop there, you completely miss the real engineering genius that's going on. Here's the critical shift in thinking. The problem isn't finding a place to store fuel. The problem is strategically positioning tons and tons of mass inside a very delicate flying structure. Once you start thinking about it that way, it's not a storage problem anymore. It's a fundamental problem of physics. And to solve that physics problem, we have to talk about something called the center of gravity. This is like the single magic point where the entire aircraft is perfectly balanced. If that point shifts too far forward or too far back, the plane gets unstable, it gets inefficient, and it becomes a real handful for the pilots and the flight computers to manage. So here's the real puzzle. Unlike your bags or the passengers, the fuel load is constantly changing. It's disappearing as it gets used. So where do you put all that weight so that as it vanishes, it has the least possible effect on that critical center of gravity? The answer is the wings. They're already right near the center of lift and balance. So as all that fuel burns off, the plane stays incredibly stable and predictable. But wait, even that incredibly important reason isn't the whole story. This is where the design goes from just being really smart to being truly, truly brilliant. This idea just flips the whole concept on its head. The fuel isn't just passive cargo waiting to get burned. Its weight becomes an active, working part of the airplane structure. Let me show you how. So when a plane is in the air, you have these two massive opposing forces. You've got lift pulling the wings up, and you have the heavy fuselage pulling the body of the plane down. This creates this incredible bending stress right where the wings join the body. But, and this is the genius part, by filling the wings with a heavy liquid fuel, that mass acts as a perfect counterweight, pushing down along the entire length of the wing. It literally counteracts the lift, which reduces the bending force and relieves a huge amount of stress on the structure. It makes the whole plane stronger. Okay, so the engineering of flight is just amazing. You have a machine that can weigh hundreds of tons, and it's about to slam into a stationary surface at up to 270 kilometers per hour. And the entire unbelievable force of that impact is handled by what look like a few little rubber tires. Seriously, how is that even possible? Let's just break down what happens in less time than it takes you to blink. The plane's wheels, they're not spinning in air. They're completely still. The instant they touch the runway, they have to accelerate from 0 to 270 kilometers an hour instantly. That smoke you always see, that's not a problem. That's the rubber literally burning as it skids for a split second, generating surface temperatures that can hit 200 degrees Celsius. And this is exactly why you just can't compare an airplane tire to a car tire. They're not even in the same league. The pressure in your car is, what, maybe 35 psi? An airplane tire is inflated to over 200 psi. That's 6 times higher. And while your car just uses regular old air, an airplane tire is filled with something else entirely, pure nitrogen. So that brings up the question, why go to all the trouble and expense of using pure nitrogen? I mean, air is free, right? Well, the answer has everything to do with safety and reliability under the most extreme conditions you can possibly imagine. It really comes down to 4 key things. First, regular air has water in it. And at 35,000 feet, that water can freeze into ice crystals and throw the tire completely off balance. Nitrogen is totally dry. Second, air has oxygen, and oxygen causes rust and corrosion from the inside out. Nitrogen is inert. It doesn't do that. Third, its pressure stays way more stable during those wild temperature swings, from freezing cold at altitude to burning hot on landing. And maybe most importantly, nitrogen doesn't support combustion. It drastically reduces the risk of a tire fire under all that heat and stress. So when you really look at an airplane, what you're seeing is this incredible symphony of solutions. The fuel in the wings isn't just about storage. It's about physics and structural integrity. And the tires aren't just rubber. They're a masterpiece of material science and pure chemistry. It is this incredibly deep, multi-layered approach to solving problems that makes flying one of the safest things a person can do. And that's what's so cool about this stuff. It really makes you wonder, doesn't it? What other things that we use every single day are built on a foundation of hidden genius that we just never even stop to see?